See student, here without taking any resistance from the resistor box, here galvanometer shows the deflection. Here deflection is 25 from the 0 toward the right side. Right? Now here we want to take the observations or readings. For that, first of here we want to take the resistance from this resistor box. Here the value of that resistance is 40. That is a 40 ohm. See here, this will be the 20 ohm, again this will be the 20. So 20 plus 20 is there, 40 ohm. And you want to type all the kids of this resistor box. Right? Here resistance is 40 ohm. Then now here we want to find out the same deflection point on this resistance wire. But here when we take the resistance 40 ohm from this resistor box, then at that time here inside the galvanometer their deflection is 15 towards the right side of the 0. Now aging jockey we want to find out the same deflection point here. Suppose here if we touch here to this resistance wire, then now here the deflection inside the galvanometer is, that is the right side of the 15. Right? If we touch here, then what we get there? If we touch here, then here this galvanometer shows the deflection toward the left side of the 15. Right? But now here we want to see the, or we want to determine, or we want to find out the same deflection point. Right? So here, suppose here if we touch here, then here deflection is again here. What we get there? Towards the left side of the 15. But again here if we touch here, see here, at 58, then what happened? At 58, with touch the jockey to this resistance wire, the deflection inside the galvanometer is 15, and without touch, again their deflection is 15. It means that with touch and without touch, the deflection inside the galvanometer is the same. Right? Then such a point called as the same deflection point. And the distance of the same deflection point from the point A is, see here, that is at 58 centimeter. And this value, this 58 value is nothing but the value of Lg, because of this will be the length of the resistance wire in front of the galvanometer. So that's why this will be the Lg. And Lr means there the length in front of the resistor box. It means that this one, the length in front of the resistor box, that is the Lr. But here the value of, that is the Lg plus Lr is 100. If we get the value of Lg is 58, then the value of Lr is simply there 42. Right? Now we want to write down this reading. See here. See here. We take the readings. That is at 40 ohm resistance, the value of Lg is 58. And the value of Lr is simply 42. And if we substitute all these values in this formula, that is G, which is equal to the capital R into the Lg upon simply Lr. Right? If we calculate this one, then the value of capital G is 55.23. Right? So this is about the first observation. Now we want to take the second observation. For the 50 ohm resistance, for that again here we want to increase the resistance by 10 ohm. See here, total resistance is 10 plus 20 plus 20. So total resistance is there 50. Then at 50, we want to find out the same deflection point. But see here, again inside the galvanometer, their deflection is at 14. Right? So here on this wire we want to find out the same deflection point. It means that their deflection is 14. Right? So here See here, if we touch here to this wire, then that galvanometer shows the deflection to the right side of the 14. If we touch here, then that galvanometer shows the deflection to the left side of the 14. But if we touch here at 50, again we shows the deflection towards the left side of the 14. But again here, if we touch here, then here, see here, with touch their deflection is 14, and again without touch, again their deflection is 14. Right? It means that with and without touch, the deflection inside the galvanometer is same. Then such a point called as the same deflection point. So the value of LG is 52 and the value of LR is simply 48. So you want to write down that. See the reading. Here, the value of capital R is 50. Then the value of LG is 52 and the value of LR is simply 48. Again, if we substitute all these values in this formula, that is capital G, which is equal to the capital R into the LG upon LR, then we get the value is 54.17. Right? This is about the second reading. Now we want to see the third one. For the 60 ohm resistance. Again here we want to take the 60 ohm from this resistor box. Already here 50. But now here again we cannot get the 10. So insert this 20 ohm resistance, again 20 ohm. So close that. So open the 50 ohm resistance. So total resistance from the resistance boxes. Now this will be the 10 and now this will be the 50. So total resistance is there 60 ohm. Then for 60 ohm, the deflection inside the galvanometer at 8. That is from the 0 towards the right side, we get deflection at 8. See here. Right? Then again we want to find out the same deflection point. See here. If we touch here, then that galvanometer shows the deflection towards the right side of the 8. Again, if we touch here, again we shows the deflection towards the right side of the 8. If we touch here, then what happened? Then this galvanometer shows the deflection to the left side of the 8. But if we touch here, there at this point, that is close to the 50, then at this point, here see here, with touch, their deflection is 8, and without touch, again their deflection is same. With touch and without touch, their deflection is the same. Right? So that's why here we get the same deflection point at 48 from the point A. And the value of LG is 48. Right? And the value of LR is there 52. So you want to write down this reading. See here reading. When we take the resistance from the resistor box is 60. So we get the value of LG is 48 and the value of LR is 52. And if we substitute all these values in this formula, then we get the value of capital G is 55.38. Right? Now, again, we want to interchange the position of the galvanometer and resistor box. Right? It means that we want to connect this galvanometer in right gap and resistor box in left gap. And again, we want to take the readings for the same resistances. Right? See here. Now, we interchange the position of galvanometer and resistor box. Here we connect the resistor box in left gap and galvanometer in right gap. Now again we want to take the readings by same method. Right? From this resistor box, again we want to take the resistance, that is the 40 ohm. That is 20 plus 20 is 40. At that time this galvanometer shows the deflection at 20. See here. Now this is the 20. Right? Again here on this resistance wire we want to find out the same deflection point. That is, with and without touch, the deflection inside the galvanometer is the same. So what we get there? If we touch here, then see here, that galvanometer shows the deflection toward the left side of the 15. Right? If we touch here, then see here, then that galvanometer shows the deflection toward the right side of the 15. But suppose here, if we touch here, see here, at this point, if we touch, then what happens? There with touch and without touch, their deflection is same. Here with touch, their deflection is 15. Again, without touch, their deflection is also 15. So that's why this point represents the same deflection point. So what we get there? Now here, the value, the length of this resistance wire in front of the galvanometer, that is the LG, and in front of the resistor box, what we get there? LR. Then their values are, that is galvanometer in right gap. See here. Here resistance is 40. That is from resistor box, resistance is 40 ohm. The value of LG is 58 and the value of LR is 42. Right? So if we calculate the value of capital G, then we get the 55.23. Similarly, we want to take the readings for the 50 and 60, and now there we want to find out the value of capital G. See here. If we take the resistance from the resistor box is 50, then we get that same deflection point at 52 centimeter from the terminal V. So the value of LG is 52 and the value of LR is 48. If we substitute in the formula of capital G, we get the value of capital G is 54.17. When we take the resistance from resistor box is 60, then at that time we get the same deflection point at 48 centimeter from the left side, and the value of LR is 52. If we substitute in capital G, what we get there? Value of capital G is 55.38. Right here, we take the readings when the galvanometer which is connected in left gap and in right gap. Now we want to find out the value of capital G here and here also. Right? And after that we want to find out the mean value of capital G. See here, we calculate the value of capital G in left gap and their value is 54.92. So approximately that value is there 55 ohm. Similarly in right gap also, that value is there 55 ohm. Now we substitute these values in this formula, that is capital G which is equal to the, right, that is the capital G in left gap and right gap. So we want to take the addition of that and again we want to dividing by 2. So what we get there? 55 plus 55 upon 2. So simply the value of capital G is 55 ohm. Right? So in this way we determine the resistance of a galvanometer by Kelvin's method. Right?